Welcome back, my gentle and of course very modern apes, to a Gutsick Gibbon video. I'm Erica, I'm your gentle and modern host, and I thought we would do something a little different today. Today I am outlining 5 big problems that still preclude Young Earth Creationism. These are going to be issues that you've probably heard before if you've been lurking around this channel for any amount of time, because they are indeed constantly coming up as these big major preclusionary problems. Now, I think it's important before we begin and dive into this little venture to note that preclusionary data is definitely different than a lack of data, right? If you don't have data to support a given hypothesis, that's not great, right? But you could always find the data in the future, right? You could find data that's going to be synthesized and then support your idea. Preclusionary data is data that knocks your hypothesis out the window. And that's the kind of stuff we're talking about today. So, problems for Young Earth Creationism. Let's get started. This video is not scripted. This is kind of something I just thought I'd drum up as a nice, easy resource for some of you out there who want 5 big preclusionary topics to discuss with your Young Earth Creationist friends. And this also has a little bit to do with the fact that the semester is starting right now for me, so I'm teaching again, and I'm also a graduate student, so I'm doing both of those things simultaneously, and I've got a lot of other videos in the works. As usual, I'm sure there will be some of you who are saying things like, Erica, why do you bother with the Young Earth Creationists? What's the point? And my answer to that is, I think it's fun, and I think it is funny. So, if you are a Young Earth Creationist out there and you don't think that it's hilarious that I spend time debunking what I think to be your, very perilously flawed worldview and outlook on science, this is an opportunity for you to answer my 5 preclusionary data sets, topics, whatever, challenges, the Young Earth Creationist challenge. Think of it like a cool TikTok challenge. You can really sink your teeth into it. I don't know why I compared it to TikTok. Most Young Earth Creationists today are far too old to be hip with the TikTok jive. Number 1, of course, gotta be the heat problem. This particular problem is actually my favorite preclusion to Young Earth Creationism, and I think we should get a little bit into why. The heat problem is my favorite preclusion to Young Earth Creationism due to its devastatingly simple mathematic truths. Essentially, Young Earth Creationists need the Earth to be 6,000 to 10,000 years old in order to match up with their literal interpretation of Genesis. This does not work with the fact that we have radiometric dates of rocks that go back to about 4.5, 4.8 billion years old. So they have to find a way to take our old radiometric dates and square them with a young Earth. The way they do this is quite simple and very, very funny. They suggest that during Noah's flood, which they suppose was a real global event where the whole planet was covered in water, that during this flood, physics just kind of broke and radioactive decay sped up. This is problematic in a way that you might not have considered if you've not been on this channel before. Essentially, radioactive decay follows the radioactive decay law in physics, and you can't just say that physics breaks arbitrarily without having some kind of, precedence for it. So there is no precedence for speeding up the rate of radioactive decay. And we know this because we've tried to speed it up. It would be very big for us if we could speed up the radioactive decay law. But we've thrown everything at it and we can't do it. More importantly, though, when radioactive decay occurs, it releases heat. So if you want to take all of the radioactive decay that has occurred in the past 4.5 to 4.8 billion years and cram it into 1 year of Noah's flood, well, that's enough heat to vaporize the granitic crust of the Earth several times over. The heat problem gets much worse than just that, though, because they also have to cram every single impact event that's occurred in the long history of the Earth into a single 1 year. They have to explain how the continents got into their current positions, which means they have to account for continental plates moving at race car speeds atop the mantle during the single year of the flood. And they have to account, of course, for all of the things like sedimentation and patterns in geology that we see as well. All of this collapses into the heat problem. Just so you can kind of get an idea about how bad this problem is with specific numbers, a chemist at Tufts has actually done the math out. And the fun thing is that this chemist actually gave them 6,000 years to get rid of all the heat, right? They're cramming 4.5 to 4.8 billion years of heat decay from radioactive decay into 6,000 years instead of the 1 year that most young Earth creationists suggest. And of course, the problem is just completely irreconcilable with their worldview. My shirt matches the background of this early 2000s webpage. But as you can see, at the time of the Garden of Eden, we're almost at 100,000 degrees Celsius. For reference, the surface of the sun is about 5,000 degrees Celsius. At the time of the Noachian flood, we're at a little less than 10,000 degrees Celsius, and at Jesus' birth, we're still over 100 degrees Celsius for the surface of the entire Earth. So this isn't going to work, is it? And this is just with the radioactive decay. This site isn't even taking into account the math for the friction of the continents on top of the mantle, the heat released from all of the impact events, including the dinosaur impact event, the KPG extinction, and they know that this is an issue, which is the fun part, right? Over here on CMI, they've noted in Too Much Heat in Noah's Flood in 2020, July 25th, that whether or not this particular figure is right, referring to the figure that someone has sent in as a question to Sean Doyle, there is most likely a severe heat budget issue for any purely natural explanation of what happened during the flood. As such, there is no simple scientific answer to this issue. Indeed, there may not be one. Then they say it's not an issue because they can use miracles. AIG similarly is trying to cope with it. They have 3 parts in their Answers research journal titled Heat Problems Associated with Genesis Flood Models. So this is something that the professionals are in fact working on, and they have been working on it for almost 2 decades. Who knows if they'll be able to fix the problem? Maybe they'll just discover new physics. But this means that the heat problem is in fact currently precluding young Earth creationism. And it does this all on its own without the need for any of the other things on this list. Of course, this is very damning because it means that there is currently no solution to it while still remaining scientific. That is to say, it is a non-scientific idea, full stop. Number 2 on this list is going to be transitional hominins. Human evolution is naturally a very big problem for young Earth creationism, but also for old Earth creationism and intelligent design advocates. So while the last one with the heat problem was specific only to the young Earth creationists, this one gets all 3 of them. The theistic evolutionists, you're still safe. This is, of course, because young Earth creationists, old Earth creationists, and intelligent design advocates believe that humans are specially created, unique from all other animals, and in many cases not even considered to be animals, although they're okay with us being mammals, but created from dirt in the image of God, and then, of course, from a rib for Eve. This means that all of 3 of these are going to be completely incompatible with what we see in the fossil record with the hominins. So human evolution makes a pretty simple prediction here, and that's that we should find transitional species that span the morphologic differences between an ancient Miocene ape and living humans today. So what are the differences between ancient Miocene apes and anatomically modern Homo sapiens? Well, there are a lot of differences. There's a lot of minutia that we could cover here, but I'm going to boil it down to two big concepts. And that's gotta be that anatomically modern humans are bipedal, we walk on 2 feet compared to other extant knuckle-walking apes, and we have enormous brains for our body sizes. We got big brains and we walk on 2 feet. So, can we find in the fossil record transitional hominins that span and show the emergence of these two traits from an ancient ape species? Yes, overwhelmingly yes. Because Australopithecines are already bipedal, and we can show this to be the case because biomechanically, with the number of species that we have and can reconstruct the entire skeleton, we know that these things could not have been knuckle-walking quadrupeds or suspensory clamberers for that matter. They have inline big toes, or halices. They have 3 arches in their feet. They have a bowl-shaped pelvis with sagittally oriented iliac blades. They have a ventral foramen magnum so that the skull can sit directly on top of the vertebral column, and they have a valgus knee to support the weight directly underneath the body. All 4 of these things anatomically modern humans also have, but more importantly, so does every archaic hominin leading up to us. Once we see these traits emerge in the Australopithecines, they stick around all the way up to us. The fascinating thing, though, is that these two traits, these two characteristics, evolve at different rates. We see bipedalism emerge quite early with the Australopithecines, as you can see there in the middle, with Australopithecus afarensis. But big brains don't really come around until mid to late genus Homo. Now, many creationist organizations will dispute this entirely, but they don't dispute it by actually addressing the criteria. They just kind of go, nuh-uh, and then they make a knuckle-walking Lucy reconstruction that is completely ridiculous, and they, of course, also don't talk about any other Australopithecus specimens, either within her species of Australopithecus afarensis or across other Australopithecine species. Now, what this means is that since all Australopithecines are already bipedal, some of our best transitional species are going to be those that are bipedal and also show an enlarging brain case size. This is going to hover, of course, naturally, around the transitional point between Australopithecus and Homo. This is because these guys already have the bipedalism, and these guys start to see larger brains, so this period in between where Australopithecus is transitioning into Homo is going to be where you find a brain case that isn't as small as an Australopithecine, but isn't as large as some of the mid to late genus Homo that is also bipedal. A perfect transitional species. So do we have these perfect transitional species? Yes, of course we do. Australopithecus africanus, for example, is a species of Australopithecine that lived in South Africa, as opposed to Australopithecus afarensis, or Lucy, which lived in East Africa. This hominin has a brain case size that can range up to 510 cc's, and we know from other species of Australopithecines in South Africa, as well as Australopithecus africanus, that this thing was also necessarily a biped. Now, after Australopithecus africanus comes Homo habilis. Homo habilis's brain case size had a range of around 500 to almost 700. 690 cc's is usually what we see. So already from the Australopithecines, the late Australopithecines, up into early genus Homo, we see the brain case going from a maximum of 500 to a maximum of nearly 700 cc's. Homo rudolfensis takes it even further. This hominin's brain case ranged from 750 cc's, already above the maximum of Homo habilis, all the way to 825 cc's. The next hominin, which is Homo erectus, averages 900 cc's, with brain cases getting as low as 600. So what we're seeing is a massive overlap and a slow gradient of change in brain case size in hominins, ranging from the late Australopithecines to early genus Homo. This is very problematic. Visually, it ends up looking something like this. We have Australopithecus afarensis, which creationists think is just a knuckle-walking chimp. They're, of course, wrong on that, with a brain case size of 400. And over on the other end of the spectrum, I've chosen Homo erectus, which most creationists would consider to be just a human, right? At 900 cc's, which is their average brain case size. So can we show the spanning of brain case increasing from early Australopithecus to mid to late genus Homo, and as I hope I've shown here and with the earlier discussion, that yes, of course we can. We have the South African hominins at 400 to 500 cc's, Homo habilis at 500 to 690 cc's, and Homo rudolfensis from 750 to 825 cc's. And this occurs over geologic time, which is a very important thing to note. And the other critical point is that all of them are bipeds. We have enough postcrania to know this. And from their skulls, we also can track, of course, their brain case size. So the way that creationists seem to be coping with this is by looking at this and going, well, actually, these guys just aren't real. They just completely erase them from the spectrum. And what they say instead, well, it just almost ate that. What they say instead, I'm just getting so passionate, is that Australopithecus ends here effectively, and Homo erectus is the start of Homo, and that these are two completely distinct kinds. And the ones that we found in the middle, they're just a mix of bones from Homo and bones from Australopithecus. This is, of course, ridiculous for many reasons, and the first that I'm going to show you is, I guess, the less well-known reason, and that's that some of these Australopithecine remains that we have, these late Australopithecines, like Australopithecus sediba here, are found in partial articulation, meaning the skeleton was found with some of the joints still intact. Now, Young Earth Creationists look at Australopithecus sediba, MH1 and MH2 are pictured here in B, figure 6. They propose that, like, the crania is ape, but the arm is also ape, and then the hand, of course, is human, but the pelvis is human too, and the legs, they don't really make a comment on, and then they split the back up. They'll be like, the upper back is ape, but the lower back is human. This is, of course, insane, because as you can see here from B, we can articulate the arm, which is supposed to be ape, with the hand, which is supposed to be human. These two things cannot articulate together if they come from two completely different species, or in their case, two completely different kinds. How do we know that they articulate? Well, one, as you can see in some of the pictures here on this very nice paper, I think it's, the reconstruction of the burial position of two hominin skeletons. As you can see from this block here in figure 3, they fit together like puzzle pieces. This scapula fits together literally like two pieces of a jigsaw puzzle. So yes, it is intuitive, but more importantly, we can use laser scanning on the articular surfaces to determine if fossils come from the same individual. Now, obviously, you can't use this for every fossil because not every fossil is indeed found in articulation, right? Or at least you can't use the puzzle piece one. You can still use the laser scanning. But perhaps the more important thing that I think young Earth creationists who like to erase the entire middle of the transition between late Australopithecus and early genus Homo is the fact that one of the best places to watch this transition occur is the skull. And if you will recall, skulls come in one piece, right? So you can't say that for for Homo rudolfensis that this section of the skull is from an ape and this section of the skull is from a human kind. Of course, humans are of course apes, but I'm using their jargon. So neither of these things work. That means the fact that this is completely bridged by species within hominins, making, of course, our transitional hominins indeed a real thing that creationists can't cope with, and thus, like at the Creation Museum, they will just completely omit them. It means that transitional hominins do indeed preclude young Earth creationism, but also old Earth creationism, and in addition to this, intelligent design proponents that don't think humans evolved from other more basal apes. Number 3 is going to be just all of statistics and their relation to common ancestry amongst organisms today. This one is also for all three kinds of creationists, the young Earth creationists, the old Earth creationists, and of course the intelligent design advocates. Once again, the theistic evolutionists, you're doing great. And I've covered this before in a video that I titled something along the lines of like statistics supports common ancestry and evolution. It did not get very good views, and I think it's because there was math in it. So I'm going to go over it here very briefly again, just so you can really understand how devastating statistics statistical work really is to creationism in general. And I've started with this paper, which is titled Statistical Evidence for Common Ancestry, Application to Primates. So what these guys did, and I really love this because they actually tested the creationist idea of this family level kinds for them, right? They just were like, we'll just do this for you guys since you're, I guess, incapable or unwilling to do it yourself. I think because they were actually afraid of the results. So they go, we focus on two main alternatives to common ancestry: species separate ancestry and family separate ancestry. That second one is going to be your kinds that creationists hold to. Now, of course, to clarify, creationists don't think that all organisms share a common ancestor, and this one is more specifically devastating because they also don't think that humans share common ancestry with other primates. But we'll talk about common ancestry in general in just a moment. So they go, we implemented statistical tests based on morphologic, so that's aspects of the anatomy and physiology, molecular, so this is your genetic stuff, and biogeographic data, and developed two new methods. One that tests for phylogenetic autocorrelation when correcting for variation due to confounding ecological traits, and a method for examining whether fossil taxa have fewer derived differences than living taxa. I love this here. We overwhelmingly rejected both species and family separate ancestry with infinitesimal p-values. We compare these results with those from two companion papers, which also found tremendously strong support for the common ancestry of all primates, and discuss future directions and general philosophical issues that pertain to statistical testing of historical hypotheses, such as common ancestry. Now, if you go specifically to the paper, you get this lovely little blurb in the common ancestry section when they were actually statistically testing the likelihood that you could get all of the different primates with their given morphologies, given genetics, and where they're found in the location on the planet Earth today, but also through the past. And here's what they said. They're trying to find out if you could get that from chance, from separate ancestry, versus through the mechanisms that we know common descent operates under. Every test of species-separate ancestry that we applied to the primates suggested that this model does a very poor job of explaining actual biological data as compared to common ancestry. Many of the data sets reject species-separate ancestry strongly, the probability of obtaining a test statistic more extreme than the one observed under the species-separate ancestry model being incredibly small, often approaching or greatly exceeding the probability of picking the correct atom at random among the estimated 10 to the 80th atoms in the known universe. This uniform and strong signal arises in part from the large number of primate species for which data are available. So that, of course, is a bit of a straw man because we don't really care about species-separate ancestry. Really, only old-school creationists think that every species was individually created. So this next one is for answers in Genesis and sort of the modern ilk of Young Earth Creationism. In the case of family separate ancestry, the fact that there are only 16 living primate families greatly reduces statistical power. Nonetheless, except in cases where we studied a single trait across families, e.g. chromosome number, testes, relative weight, etc., tests of family separate ancestry also showed extremely strong support for common ancestry. So this really just completely boots the idea that kinds are a thing, but we'll touch more on kinds a bit later. So statistics within primates annihilates Young Earth Creationism. Too bad you're an ape. I've never actually seen really Young Earth Creationists tackle this. But we also have Beyond Reasonable Doubt, another paper that was released somewhat recently, and it's called Beyond Reasonable Doubt, Evidence from DNA Sequences. I'm just going to read you the abstract so you can get an idea of what's going on here. They go, we demonstrate quantitatively that as predicted by evolutionary theory, sequences of homologous proteins from different species converge as we go further back in time. This shouldn't happen if things were created uniquely, right? The converse, a non-evolutionary model, can be expressed as probabilities, and the test works for chloroplast, nuclear, and mitochondrial sequences, as well as for sequences that diverge at different time depths. So they give you some numbers, but it ends with this. By comparison, there are about 10 to the 80th protons in the universe, hence the probability that the sequences could have been produced by a process unrelated to ancestral sequences, so unrelated to common descent, is about 10 to the 50th lower than picking among all the protons the same proton at random twice in a row. A non-evolutionary control model shows no convergence and only a small number of parameters are required to account for the observations this time that researchers insisted that doubters put up testable alternatives to evolution. So this one's a real hit at intelligent design advocates, right? You have to be able to show a mechanism for why we see these patterns both in primates and in the tree of life as a whole that is unrelated to common ancestry. Otherwise, it's just vague gesturing. So number 3, statistics, and in relation specifically to common ancestry, but statistics precludes any variant of creationism. For number 4, we have the energy industry. I like this one because it's got a very easy proof and it's easy to understand. Essentially, all of our fossil fuels, coal, natural gas, oil, things like this, they're all formed by geologic processes. No one would deny this to be the case, right? So we find them using things like basin modeling, a process that involves radiometric dating and the assumption that radiometric dating, a process rooted in the radioactive decay law, works. So can we actually find natural fossil fuels, things like that, using basin modeling? The answer is, of course, a resounding yes, because every part of the energy industry utilizes basin modeling and radiometric dating in order to actually fuel our global economy, which is something like a $257 billion annual industry. It's a lot of money if the underlying assumptions of the Earth being very ancient, something that is, of course, foundational to radiometric dating working, is false. So I pulled up a paper here called A Novel Geochemical Toolbox for the Petroleum and Mineral Industries, just to show you kind of what I mean. This was a semi-recent paper, and basically what they've noted here is that they found another cool way to radiometrically date things, right? So the underpinning research highlights right here showed that the iridium-osmium chronometer is a reliable, precise chronometer for obtaining the depositional age of classic marine and lacustrine sedimentary rocks. It illustrated the utility of this method to define the age of oil generation from a source rock, and it demonstrated how iridium-osmium, platinum, and palladium geochemistry can be used to characterize fingerprint crude oils. Discovered that it's an isotope system, and this various systematics can be used to ascertain the timing of oil generation and identify an oil source rock age in sedimentary basins by analysis of oils alone. It developed an understanding of the optimal use, of molybdenite and other sulfide minerals for precise iridium-osmium geochronology in ore systems, and demonstrated independently that the radium decay constant is accurately and precisely determined, critical knowledge underpinning radium-osmium geochronology, So, I hope this demonstrates just how important knowing the age of different rocks is for being able to fill up your car or heat your home. This is obviously very problematic to young Earth creationism in particular, not so much old Earth creationism or intelligent design proponents, but this is just very damning, right? The entire economy of our world depends on fossil fuels, and they use processes associated with the ancient age of the Earth to find them. So I would say that very simply, the energy industry does indeed preclude young Earth creationism, number 4. And lastly, number 5, I've picked Comparative Genomics. So as many of you might know, young Earth creationists, old Earth creationists, and to some degree intelligent design proponents all suppose that evolution either doesn't happen or it has certain limits. And if that is indeed the case, you can't have a common ancestor for like dogs and bears. Instead, there was a created dog and a created bear that then diversified within that family level into various organisms that we now consider them to be closely related to today. Of course, the problem with this is, and you guys will know they dub those created kinds, is that there is no line to delineate within genetics. Allow me to explain. In comparative genomics, right, an example that we see every day in my country, the United States, is that of a paternity test. A paternity test is comparative genomics scaled down, and what it effectively does is it takes a highly variable region of the genome and it looks at it between individuals who may or may not be closely related. The more similar the genomes, the more likely it is that that individual who's matching that of the child is the father. Right? The more similar the genomes, the more closely related to individuals within our species are. This is why if you took 100 random genomes and then stuck your mother's genome into it, anybody who knows anything about sequencing genes would be able to look at all of those genomes and pinpoint which one's most closely related to you. It'll be the most similar, and it will be that of your mother. Similarly, your grandmother is very closely related to you genetically, right? So her genome is going to be very similar, but not as similar as your mom's, and so on and so forth, all the way back through time. Now, creationists take this to a strange level because they are fine with comparative genomics, of course, working within the human species. They're even fine with using comparative genomics within and between other species that aren't humans. So they're okay with us looking at the genomes of a lion and a tiger and saying, well, they're 95% similar, so these two things are probably closely related. Probably more closely related than either is to, like, a wolf. But the weird part about that is that because of their created kinds idea, they don't think that that goes back all the way to a common ancestor, despite the fact that we know of no genetic demarcation, no floodgate that stops relatedness the further back we go in split-offs in sort of cladogenesis. So this becomes very weird when we look at where humans fit in, because humans are, of course, most closely related to chimpanzees and bonobos, and those two animals are, of course, most closely related to us. More than they are to, like, gorillas or orangutans, and more than we are, of course, to gorillas and orangutans. And that's at about 98.8% if we're looking at alignable regions, 96% including insertions and deletions. Creationists would say that we are not related to them, despite the fact that they're fine with lumping rats and mice at around 95%, and elephants and African and Asian elephants at around 95% as well. This is inconsistent, but more importantly, they don't have that genetic barrier that delineates the kinds. It doesn't exist. And this is the case, no matter which group of organisms we look at. As you saw earlier, statistically, we can take it back to like a last universal common ancestor, and it's effectively still the case. So they lack their genetic barrier to basically falsify evolution. That's what would falsify it, some kind of floodgate, as I mentioned earlier, that stops at the end of the kind or family level, but it doesn't exist. So here are our 5 topics that entirely preclude young Earth creationism. Now, in my bite-sized bus videos, I usually go about saying how I think they'll respond or how I think they'll try and fix the problem, but because a lot of these are long-time running problems, the answer to most of them is just they'll ignore it. Right? The heat problem, they'll probably eventually give up and say, okay, we have to have a miracle. But then they'll say, but evolutionists have to appeal to a miracle themselves for like the Big Bang or, abiogenesis or something along those lines. Again, the theistic evolutionists here are coming out on top over all of the other kinds of sort of theists here. Hominins, they're just going to keep ignoring those transitional hominins. There is no reasonable way by which they can write it off as a mix of Australopith bones and Homo bones, like if you even look in the general direction of the data. So they'll just keep ignoring them, I think. I don't think we'll ever see any wrap-ups on that or any comprehensive answers on that. Statistics, that's going to be a tough one for them. They generally just ignore this one as well, or they appeal to, but you're straw-manning us. Okay, well, there did species and family separate ancestry, so either you give us a better definition that is more standardized for kinds, so we can test that, or better yet, do it yourself, or shut up about it. The energy industry, that one they're going to ignore, 100%. Like, it is insane to me that they think that there could be this grand coincidence of a bunch of different geologic processes kind of moving in lockstep to give the appearance that the Earth is very ancient, because these processes do corroborate each other, right? The same basin modeling that we use to find coal is used to find other things like natural gases. And for comparative genomics, this one is also going to be an ignore, I think. Or they might just kind of flap around and point at various genetic phenomena, if you will, and progressively change which genetic phenomena they feel is going to be the most taxonomically restricted. They've done this before with things like orphan genes. The problem is, if you use orphan genes, every species has its own orphan genes. Then you end up with the kind being a species. They can't do that because they can't fit them all on the boat. So I think with comparative genomics, there will be a lot of floundering until we eventually get here. If you are a young Earth creationist and you think, if you're a young Earth creationist and you think that you can solve this problem, by all means, please do. But as usual, I think it's safe to say that we've given 5 good TikTok level challenges for creationists to kind of cope with. Maybe we'll learn something new. Maybe they'll bring some new physics to the table. Until next time, I've been your gentle and of course very modern ape host, Gutsick Gibbon, and please do take care of yourselves.